It'll be the 15th.
It's not, no. It's like, one thing is like right here, the next is like.
Yeah. We're going to create a graph from an equation.
I told you I started when you began. Yeah, sure. Hey, you saw her 20. Yeah,
Okay, so we have an equation here, right?
Did I not give you two? Oh. Thought I messed up there. You did.
So yesterday, if you recall, we were finding slope and y-intercept from an equation, right? So we should, because this is in slope-intercept form, we know that our slope is what? -2. And our y-intercept as an ordered pair is 0, 2. Okay, so those are kind of like our directions of how to, those are what we need in order to now graph this line from this linear equation, right? So the first step is to plot the y-intercept. That's my first step. Plot the y-intercept. That looks like they intercept, doesn't it? Let me fix that. Okay, so I go to 0, 2. Remember, that's the point where the line crosses the y-axis. I need rulers today.
Are we gonna keep these ones?
I'm sorry?
Are we gonna keep them?
You're going to keep the rulers?
Yeah.
No. That's what class says.
I got you.
Too expensive.
They're kind of
I
expensive.
think only
5, 6, 7.
Yeah. Why do you?
8.
Alright. You're gonna just use it.
Literally all right than we got.
And then you can send my on the back sheet.
Okay. So the reason I passed out a ruler is so that your graphs can look accurate. Now that we have our y-intercept, we use that as kind of our starting point. And then we use the slope to plot 3 more points, right? Because remember, the slope is the distance between the 2 points and in the direction we go in, right? So since our slope is -2, that tells us we're going to go down 2, right 1. Because our slope is -2. So that's it. That's our fall, down 2 over 1, down 2 over 1, right? Because that's just the way slope works. We just don't write -2 over 1. I mean, you can if you want to as an improper fraction, right? And so this tells us, this is another reason why we go from left to right. We know we're going to go down and over, and we're always going to be moving to the right. If you do the rise or fall first, then you'll always go to the right and you'll always be accurate. So you need to go down 2 over 1, down 2 over 1. If there's enough room, you should get 3 more points. If there's not enough room, I mean, then there's just not enough room on the graph. But your goal should be to have 4 total points, including the y-intercept. I have students that like to then plot up and over 2 so they can be super accurate, but that's personal choice.
I'm putting this on a second. Yeah, I do.
Right, so then we have our graph. And that's how you use an equation to create a graph. You identify the slope and y-intercept, plot the y-intercept, and then use your slope to plot, if you can, 3 more points. If you can't, I mean, that is what it is. If your slope has like very large values. We'll do one more. Okay, let's do this equation. Y equals 3/4 x plus 7. So I'm going to identify my slope and my y-intercept. So slope is 3/4. Y-intercept is what as an ordered pair? 0, 7. So I'm going to do the exact same process I did on the first one. I'm first going to plot my y-intercept. That's okay. And then my slope, because it's 3/4, that tells me up 3, right 4. Because that's my slope. So if the goal is to plot 3 more points, can I go up 3 and over 4? No. So you kind of have to do the opposite. You're going to have to go down 3 and back 4, right? If you can't fit it on the graph because the graph doesn't extend that far, then you just go the opposite. It's down 3, back 4. And you can see how if I could have extended it, it would continue on in that same direction. Can I even plot another point? Nope. So sometimes that's going to happen. And then that's all I can do on this graph.
What was the second bullet point for the front one?
We use the slope to plot 3 more points. So write yourself a little note. We could not go up 3 and right 4, so we went down 3 and left 4. And then like that, you can visualize how it would extend on the graph if your graph was bigger. I'm going to come around while you guys are finishing up and give you 2 pieces of paper. Keep both of them. Do not pass anything along. These are both for you. And we're just going to do a little activity of practicing graphing equations. Thank you. A couple things we need to do. Like I want to demonstrate a couple of these 4. You are going to need your ruler. So don't try to give that back to me yet. you'll want to color a design, but I would wait till you're done. If that makes sense. Okay. So we have this stained glass blueprint. Right? We're going to read through the directions together to make sure we all understand what's happening.
Do we need the glue stick?
Nope, you don't need the glue stick anymore. Nope, good question. We probably do. We'll save it for Monday. Okay.
Okay.
All right. So the directions say, graph each line on your paper using pencil. Everybody see where it says pencil? So don't do this with marker or flare pen or red pen or pink pen or blue pen. Get out a pencil. Make sure that your lines are straight by using a ruler. Everybody has a ruler. Extend the lines to the edge of your paper. Okay, so make sure that when you are drawing the lines, you go all the way at least to the outside edge of the graph. Okay, don't stop here if you're drawing a line. Like, make it go all the way as far as it can go on the graph. Is everybody with me?
Yeah, sure.
Okay. When you have finished graphing all the lines, color your design to create a stained glass window. So once you're done with all of the lines, you'll see like a pattern and you get to decide how you want to color it. There's no like color by number or anything. You just get to color. You may wish to go over certain parts of the design with a dark pen, crayon, or marker to emphasize different portions. You guys all know what a stained glass window looks like, right? You can kind of see the borders in between the different colors of the glass. Okay. So we're going to graph all these lines using our point slope form that we just started. After you have graphed all the lines, plot these points. Connect them in the order that they are plotted. For example, graph -2, 0, then graph 0, 4, and connect it back, right? You guys have done these before your whole life, right? Where you plot, connect, and then you stop, meaning this is not going to get connected to this point. And then you plot, connect, stop. And then you start a new one. Yes?
So should we do all the points first and then go down
Nope.
to here?
Oh, you mean all the lines first?
Yeah, like up
Yes.
here, do those first.
Graph all the lines first, and then do these little plot connect sections. Again, with a ruler.
Do we only do 1 point from the intercept form? And is that the like, so since the first one's -3, 2,
Mm-hmm.
we would go down 3, right?
So you would go to 0, 12, you go down 3 over 2, down 3 over 2, a few points, and connect those.
So do like 2 or 3 points?
Yep.
Okay.
As many as you can on this graph because, I mean, the lines are pretty, you might not be able to do that.
As many as you can.
Well, at least 3, unless you run out of space. Okay, and then does everybody understand how you don't connect this -2, 0 up to this 0, 10?
Yeah.
These are different sections of the design. Yes?
Yeah.
Okay, so let's do a couple of them together because I know that we probably forgot already. Let's look at number 9. Somebody tell me, what is this line going to look like? It's a y equals 12. What does that tell me, Eden?
It's going to be horizontal.
Mm-hmm. At y equals 12. So I'm going to go over here. I know it's kind of hard to see the colors, the numbers, but you can also just count the lines. And I'm going to take my ruler, and I'm going to go to this 12, and I'm going to draw a dark line there with my pencil. And then I can check that off the list. Number 9, I got that one done. Right? Yep, y equals 12. Yep, horizontal line. Yep, you got it.
Oh, that's nice.
So what would number 11 be? What would number 11 look like? If y equals 12 was a horizontal line at 12, what will the line look like for equation number 11? What do you think, Avery?
Horizontal line at -12.
It's not going to be horizontal, it's going to be vertical, right? Gotcha. That would have been a horizontal line at -12. So now I'm going to go over here to my graph, and I'm going to find -10. And I'm going to draw a vertical line.
Do you want us to do the arrows? Because I'm just thinking when we're like drawing that it may look a little weird.
Well, if you're going kind of to the edge, it won't really matter.
Okay.
Yeah, it's not like the arrows are going to be in part of the design. Okay, so you now only have 10 other lines to draw using your slope-intercept form and all that fun. And then you're going to do these little point sections, and then you get to color. Yeah?
Do you want us to stay like this or can we move around?
I think the problem with moving around is then you get too many people at a desk, and you kind of need some space for this. Like people like to try to share a
Can we
desk,
switch
and
seats
that gets a little awkward. If
so that we have our own desk?
if someone wants to switch with you, you can work that out with someone.
Just because someone is this?
Nope, that's -10 and this is 10. So one of them was in the -10
I don't honestly
over here. The other one's going to be a +10 over here.
Oh, I thought it was on that.
Yeah.
Okay.